well, this is section R.3. This is the first section of the first unit of Algebra 3. Welcome back, everybody. This unit is doing some review of some Algebra 2 concepts that we've learned. So this should be review for everyone. The first thing we're going to talk about is exponents. And whenever you're multiplying numbers, first thing you're going to do is look at the coefficients, and you actually do multiply the coefficients. Multiply coefficients, those are the numbers in front of the variables. And so in this case, my coefficients are 4 and 6. So when I multiply those, I get 24. And that's only for the coefficients. When it comes to the variables, when we multiply variables, the rule is that we add their exponents. So when you multiply variables, you add exponents. So if I've got x to the m times x to the n, that becomes x to the m plus n. That's the rule that we used. So here my variables are x squared and x to the 4th. So I'm going to add the 2 and the 4, and that's x to the 6th. And so your answer is 24x to the 6th. So we're going to apply that to this next problem. My coefficients are 5 and negative 8. So 5 times negative 8 is negative 40. You multiply the coefficients. And then when we multiply variables, we add the exponents. First, I'm going to look at my x term. And remember, if you don't have an exponent, you assume it's a 1. So I'm just going to put that in there as a little reminder. X to the 4th times x to the 1st. You add the exponents, so that's x to the 5th. And then I'm going to do the same thing with my y variable. There's no variable here, or no exponent on that variable, so that we assume it's a 1. So I have y to the 1st and y to the 8th. If I add those, I have y to the 9th. So that's sort of our review of when we multiply terms, multiply the numbers in front, the coefficients, but you add the exponents on the variable. When we divide terms, we divide or simplify the coefficients. But on our variables, when we divide variables, just like when we multiplied, we added. When we divide, we subtract the exponents. So when we divide variables, we subtract exponents. So I have x to the m over x to the n. This is what the rule looks like. I'm going to take the numerator minus the denominator. That's really important. Whoops, let me get that so you guys can see it. It's really important that you make that distinction. You're taking the numerator minus the denominator. So in this first one, I've got my coefficients are 8 over 2. 8 divided by 2 is 4. And then on my variables, I have these are both x terms. I have 5 in the numerator, 2 in the denominator. 5 minus 2 is 3. So that's 4x to the 3rd. So let's try that on another one. This time I've got 16x to the 4th, y to the 7th. I'm adding another variable into this one. And 4x to the 9th, y to the 7th. First thing we do is we look at our coefficients, and we're going to divide those. 16 divided by 4 is 4. Or if you wanted to simplify it, 4 goes into 4 once. 4 goes into 16 times. 16 4 times, excuse me. So that's what I mean by simplify. When I look at my x variable, remember you take the numerator minus the denominator. So here I have 4 minus 9. 4 minus 5, mine is a negative 5. And we'll deal with that negative exponent in just a minute. And then for my y variable, 7 minus 7 is 0, so it's y to the 0, which gives me a chance to do a little reminder on what we do with negative exponents and 0 exponents. Negative exponents when we have a negative exponent, we move it to the other level. So if it's in the numerator, we put it in the denominator. If it's in the denominator, we move it up to the numerator. and you make the exponent positive. Okay, and that rule is, if I've got x to the negative n, I would move it to the denominator, so it would become 1 over x to the positive n. Or, if it was already in the denominator, if I had x to the negative n, I would move it up to the numerator, and that would become x to the positive n. Okay, so wherever that negative exponent is, you move it to the other level. So for this problem, I've simplified the 4, that's not going to change, but my x term, since it has a negative exponent, is going to get moved to the denominator, so this is going to be over x to the 5th. And then whenever we have 0 exponents, any variable to the 0 equals 1. So the rule is x to the 0 equals 1. So y to the 0 is 1, and anything times 1 is itself, so my final answer here is just going to be 4 over x to the 5th. Okay, now we're going to use all of that information and apply it to number 5. 8 divided by 32 is going to be a fraction, but you can simplify because 8 goes into both of these terms. 8 goes into 8 once. 8 goes into 32 4 times. And then my x has a negative exponent. Remember, if we have a negative exponent, we're going to move it up to the other level, so it's going to move to the numerator. So this is going to end up being x to the positive 6th in the numerator times the 1. And in the denominator, all I have left is the 4. Next rule that we're going to review is the power to a power. And we have a term being raised to a power. So I have x to a power, and that's being raised to a power. We call that power to a power. And when you have that, you multiply the exponents. So x to the n, if it's raised to the m power, you multiply those, and that's x to the nm. That's the rule that goes with. And every single part of the term gets raised to the power. So in this first one, the exponent on my 6 is like a 1. 1 times 3 is going to be 6 to the 3rd for my coefficient. So even the coefficients get raised to the power, not just the variables. My variable is x to the 4th. 4 times 3 is 12, so that's going to be to the 12th power. And then I do need to go ahead on the coefficients and work those out. 6 to the 3rd power is 6 times 6 times 6, which is 216. And then we have x to the 12th. When you get to things that are a little bit more complicated, like number 7, there's a lot of stuff going on here, and this is where we need to remember PEMDAS. Or, please excuse my dear Aunt Sally, it's all order of operations. And the order of operations is still really important. So I always start with what's inside the parentheses. So what I do is I look inside the parentheses and I see, is there any way that what is just inside the parentheses can be simplified? And it doesn't appear to be here. So the next thing are your exponents. And we're going to do one term at a time. This term is being raised to the 3rd power. I'm going to go ahead and put 1s for exponents on the ones that don't have exponents to remind me that that's a 1. Each one of these exponents is going to be multiplied times 3 because this is the power to a power rule. So this term is going to become 2 to the 3rd. 4 times 3 is x to the 12th. And 1 times 3 is y to the 3rd. Again, the coefficients you want to go ahead and multiply out. 2 to the 3rd is 2 times 2 times 2, which is 8. So we have 8, x to the 12th, y to the 3rd. That solved that exponent. Remember, that's the second part of PEMDAS. And I'm going to do the same thing for the next term. For this term, everything inside this parentheses is being raised to the 2nd power. I'm going to put 1s on the ones that don't have exponents, just to remind me of what they are. And then each of these exponents gets raised to the 2nd, which means we're multiplying it. So 1 times 2 is 2, so this is 3 to the 2nd. X. 5 times 2 is 10, so it's x to the 10th. 1 times 2 is 2, so it's y to the 2nd. And on the coefficients only, we're going to go ahead and multiply that out. 3 squared is 3 times 3, which is 9. X to the 10th, y to the 2nd. And because these two terms are next to each other, there's an implied multiplication between those. So we still have to multiply these two. That's my next step in PEMDAS. And we're going to go back to our multiplication rules. Remember, when we multiply the coefficients. 8 times 9 is 72. But we add exponents. So for my x, I've got 12 and 10, which is 22. And for the y, I have 3 and 2, which is 5. There's nothing else. There's no more parentheses. There's no more exponent work that needs to be done. No more multiplying or dividing or adding or subtracting. This is then my final answer for that particular problem. Okay, so that's if we were multiplying two terms. They're being raised to a power. This one, we've got a division problem being raised to a power. And I'm still going to refer back to PEMDAS. And we're going to do inside the parentheses if we can. If I can simplify my coefficients, I would, but there's nothing that goes into both 5 and 6, so there's really nothing to simplify there. I only have one variable for one x variable and one y variable, so there's nothing to simplify inside the parentheses. So my next step is to look to my exponents. And remember that everything inside the parentheses is getting raised to that 4. And so I always put 1s wherever there isn't an exponent, just to remind me of what we're doing. So this is going to be raised to the 4th power, so this is going to be 5 to the 4th. 2 to the 4th power is going to be 2 times 4, which is 8, over 6 to the 1st. 1 times 4 is 4, so this is 6 to the 4th. And 3 times 4 is going to give us y to the 12th. The coefficients need to be multiplied out. So you can take 5 to the 4th power is 725, x to the 8th. 6 to the 4th power is 1,296, and then you've got y to the 12th. There's nothing you can simplify between 725 and 1296, so that would be your final answer. We're going to do another one like that, but this one's going to have some negatives in it, and we're still doing PEMDAS. And as a general rule, I don't like to do the negatives until the very end for the x, move the negatives at the end, because what's negative now might not be negative if it gets multiplied. So it's just good to not move stuff around until the very end. So I'm going to look inside my parentheses. I have an x, a y, and a z term, so there's nothing to simplify in there. So I'm going to take each of these and raise it to the -6th, which means I'm going to take the exponents and multiply them. -3 times -6 is a positive 18. So see what I mean? I didn't want to move the x because it became positive. Y to the 2nd to the -6th is y to the -12th. And on the bottom, z to the -4th to the -6th is z to the positive 24th. Now I only have one negative to worry about. That's the y to the -12th. And because that's a negative exponent only for that variable, I'm going to move that to the other level. Everything else is going to stay put. So x to the 18th stays in the numerator because it's positive. Z to the 24th stays in the denominator because it's positive. But the y is going to come down to the denominator and become a positive exponent. And then that would be your answer. If you were going to, if you're checking your answer and it didn't look right, remember that the answers are usually going to be in alphabetical order. So even though this is correct, if you want to get it to match, make sure that everything is in alphabetical order. So this would be y to the 12th, z to the 24th. But the value is the same. The value doesn't change. I just don't want you to be confused if you're checking your work and it doesn't look exactly right. Make sure everything's in alphabetical order. Okay, so we're going to try this one more time. Remember, always go back to PEMDAS and pay attention to where the exponents are. If you look at number 8 and 9, the entire fraction was inside of parentheses and was being raised to this power. This entire thing was inside of parentheses and being raised to this power. On number 10, only the numerator is being raised to the 2nd. The parentheses does not extend down to the denominator, so this denominator is not being raised to the 2nd. And under PEMDAS, you're going to do parentheses first. There's nothing to do inside the parentheses. That's as simple as that's going to get. I'm going to do my exponent next. So I'm just going to focus on this numerator and taking each of these powers and raising it. Power to a power means we multiply powers, so this is x. -3 times 2 is to the -6th. Y, 5 times 2 is to the 10th. And then in the denominator, that's not changing. It's x to the 6th, y to the -3rd, because it's not being raised to a power. All right, now that I've done that, we're going to simplify. This is a division problem. I've got variables on the top and the bottom. if I look at my x variable, remember when we subtract, you take the numerator minus the denominator. So this is negative 6 minus 6. So that's x to the negative 12. Be really careful of that, because some people will look at that and go, oh, that's 0. Well, and it's not 0, because you're not adding them. If you were adding them, it'd be 0, but it's subtracting. It's the top minus the bottom. Numerator minus the denominator. Be very careful of that. And that's going to play out here in this next one, because I have 10 minus 3. One of the biggest mistakes people will make is they'll put y to the 7th. But it's not y to the 7th, because it's 10 minus a negative 3. Well, 10 minus a negative 3 is 10 plus 3, which is actually 13. And that's one of the biggest mistakes that people make when they have negative exponents and they're dividing. Okay, you're taking the top minus the bottom. If it's minus a negative, we know that when we subtract a negative, it's a plus. And then finally, we're over here, and this is a positive exponent, so the y is going to stay put. It's going to be y to the 13th on the top. This is a negative exponent, so it's going to go to the denominator to become positive. So this is y to the 13th over x to the 12th. And your homework problems are listed for this exponential part of the notes.